Let's be honest, probability questions on the ACT can feel like a total shot in the dark. But what if I told you there's a simple strategy to get them right every single time? Well, that's what we're going to do today. We're cracking the code on ACT probability. Let's jump right in.
You know the classic coin flip, right? Heads or tails? It feels like a simple guess, but it's actually the perfect starting point. Because probability is the math that explains why it's a 50-50 shot. It's all about understanding the odds, not just guessing.
Okay, burn this into your brain. This little formula is your golden ticket. Seriously, every single probability question, no matter how weird or complicated it looks, boils down to this one simple idea: what you want to happen divided by everything that could happen. That's it.
So let's use that formula on our coin toss. We want heads. That's one desired outcome. What are all the possibilities? Well, it can be heads or it can be tails. So that's two possible outcomes. 1 divided by 2. See? Simple.
All right, let's level up with a typical ACT-style problem. You've got Mara. She has a basket with 50 total beads, and 10 of those are red. So what's the probability that she'll reach in and pull out a red one? Just think back to our formula. What do we want versus what could we get?
Exactly, you got it. There are 10 red beads we want out of 50 total beads possible. So that's 10 over 50. And if you simplify that fraction, you get 1/5. See? That core formula is your best friend. It always works.
Okay, so you've got the basics down. But the ACT loves to add little twists. So what happens when they give you more than one way to win? We call this the either-or scenario. And the great news is, this actually makes your chances of succeeding go way up.
So let's go back to Mara's basket. This time, a win is picking a red bead or a green bead. We know there are 10 red ones and 15 green ones, still out of 50 total. That word "or" is a massive clue. When you see it on the test, a little light bulb should go off in your head.
And here's why that light bulb goes off. The rule for "or" is just add. It's that simple. Now for Mara's beads, a bead is either red or green. It can't be both, so we can just add the probabilities. But here's a pro tip for a trickier question. What if you were drawing from a deck of cards, and the question was king or a heart? Well, you can't just add them, because you'd be counting the king of hearts twice. In that case, you'd have to add the probability of king and the probability of heart, and then subtract the overlap, the king of hearts.
So, back to our beads, which is much simpler. The chance of grabbing a red one is 10 out of 50. The chance of grabbing a green one is 15 out of 50. Since it's an OR problem, we just add them together. That gives us 25 out of 50.
And what does 25 out of 50 simplify to? 1/2. Look at that. Her chances went from 1 in 5 for just red all the way up to a 50-50 shot. So remember this. OR means more options, which means your probability is always going to go up.
All right, now for the flip side. If OR is your helpful friend, AND is, well, it's the one that makes things a lot harder. This is the both-and scenario, where you need multiple things to happen in a row. And as you can probably guess, this narrows your chances a lot.
The classic example is rolling dice. Imagine you've got 2 of them. What are the odds that you roll a 6 on the first one and you roll a 6 on the second one? That word "and" is the key. It means you have to succeed twice, not just once.
And the rule for AND is totally different. You can forget about adding. When you see AND, you have to multiply the individual probabilities together. This is a big one to remember.
Think about it. The chance of rolling a 6 on one die is 1 in 6. The chance on the second die is also 1 in 6. So we multiply 1/6 by 1/6, and we get 1 in 36. Whoa! See how much smaller your odds just got? It's much, much harder for both things to happen.
Okay, you might want to screenshot this slide. This is your ultimate cheat sheet. If you see OR, you add, and your odds go up. If you see AND, you multiply, and your odds go down. If you can just lock this table into your memory, you'll be in fantastic shape.
And here's a quick sanity check you can use on the test. Just stop and ask yourself, does my answer make sense? It's always going to be harder for 2 things to happen than for just one thing to happen. So if you do an AND problem and your answer is somehow bigger than what you started with, you know you made a mistake somewhere. It's a great little gut check.
So we've got the rules, we've got the logic. Now let's get our hands dirty and use this stuff to solve a problem that feels like it was ripped straight from an ACT test booklet. This is where we put it all together.
All right, here we go. We've got a jar. Inside, there are 12 red marbles and 20 other marbles, which means there are 32 total, right? The challenge is,
How many more red marbles do we need to add to the jar so that the probability of picking a red one becomes exactly 3/5? Let's call this mystery number X.
Let's break down how to set this up. We start with what we know, 12 red out of 32 total. Now we're adding X new red marbles, and here's the absolute key, the part everyone messes up. You have to add X to the top because that's how many red marbles you have now, but you also have to add X to the bottom because the total number of marbles in the jar has also increased. So our new probability is 12 plus X over 32 plus X. We set that equal to our goal of 3/5, and now it's just an algebra problem.
And when you cross-multiply and solve it all out, you find that X equals 18. You need to add 18 more red marbles to that jar to make the probability 3/5. See? Not so scary when you know how to set it up.
Okay, so let's recap the big ideas. Number 1, everything starts with that golden rule, desired over possible. Number 2, or means add, and your odds get better. Number 3, and means multiply, and your odds get worse. And finally, always take 2 seconds to ask yourself if your final answer actually makes common sense.
And just to really hammer home how powerful these ideas are, think about this crazy fact. The odds of winning the lottery are so tiny because it's an and problem on a massive scale. You need to get this number right and this one, and the probability just plummets. It's so low, in fact, that you're way more likely to get struck by lightning. Kind of puts it in perspective, doesn't it?
After breaking it all down like this, I'd say the odds are pretty darn high. Because now you know that probability isn't some random guess. It's a strategy. And now you have the tools to ace it. You've got this.